Hi, I'm Dale Johnson, Field Service Manager with Horton. We're here at the Horton Research and Development Center, and today we're going to go over the Horton LCX and RCX fan drive operation, diagnostics, and inspection. We're going to start off today with the Cummins engine. And the Cummins engine, indifferent from a Packard engine, incorporates a Horton DI controller. The Horton DI controller is an interface between the engine ECM and the fan drive, similar to that of a cable box on your TV. It basically takes the signal from the engine ECM and converts it to a frequency so the fan drive can read the signal. Today we're going to check the function, operation, and the electrical connections for the fan drive. First, we're going to check to see if we have any codes or the flashing sequence of the DI controller. The DI controller is self-diagnostic with a series of flashing codes: red, red and yellow, green and yellow, steady green. With the DI controller, a steady green light means that all of your signals and electronic functions and connections are correct. A flashing red and yellow signal on the DI controller indicates a short somewhere between the fan drive and the DI controller. If you have a yellow and green flashing LED, that indicates that you have the incorrect CAN message coming from the engine harness. If there's a steady red light, that means there's no CAN signal at all coming from the engine harness. If there's no light, that means there's no power going to the controller from the engine harness. If you have a red and yellow LED light, you'll want to remove the adapter harness and do a resistance check on the fan drive. This is the fan clutch lead going from down here inside the fan clutch up here to the DI controller. We got 5 wires here. We got a red wire. We have a blue wire. The red and blue wire are the power and ground that control a valve inside of the fan drive. We also have a pink with a black stripe and a green, which are power the Hall effect sensor that's in the fan drive that monitors the fan speed. And then we have the 5th wire, which is a yellow wire, which is the fan speed feedback. The fan drive feeds the speed back into the ECM, and the ECM knows how fast the fan drive needs to operate. So by controlling the current that goes to the red and the ground to the blue wire, it controls the fan speed. We want to check the resistance between the red wire and the blue wire, which are your power and ground for the fan drive. So we'll get a couple probes here to probe this. Get our ohm meter here, get that set up. And right here we got a resistance of 11.1. So we have a good resistance. So if there isn't contact, or we got a bad coil or a damaged wire or something, you will have 0 resistance or out of limits. So the resistance on this particular truck or on this fan drive is good. If the coil was bad, you'd have an out of limits reading on the resistance. When reconnecting the fan drive after the resistance check, you want to check the part number of your old adapter harness. Adapter harness part number 103468 should be replaced by 103803. So we want you to put that in. If it doesn't have the new one, put the new one in. With a steady green light, once you start up the engine and it's not calling for cooling, you take it up to about 12 to 1500 RPM. Within 3 to 7 minutes, the fan drive should disengage to about 150 RPM. If the fan drive does not disengage, then there's an internal mechanical defect within the fan drive. If your fan drive isn't engaging at all or staying at a very low speed, you'll need to check the fan drive for fluid leakage in and around the fan drive area and mounting bracket. If no leaks are present, then it is most likely an internal defect within the fan drive, and the fan drive will have to be replaced. When you're reinstalling the DI controller, if the bracket is broken, you can simply use zip ties to tie it securely in place. That completes the fan drive diagnostic and testing. If you have any further questions, please contact us at Horton. Thanks for watching.